we want to solve the inequality. We can make it be compared to 0 if we subtract one term to the other side. This gets all the terms onto one side. And then what you have is you have the thing being compared now to 0, like in some previous problems that we had. This one's a little bit more complicated than some of the previous problems, though, because it's not just one fraction here being compared to 0. What I would do then is I would get a common denominator so that we can combine this guy into being one fraction. So the technique for converting a fraction into having a common denominator, that would be introducing the multiplication of a fraction of your choice on both of these terms. Look at what the denominators are now and see how they're different and how they could become a denominator that would be a common multiple of the two. So what would be a common multiple of those two, of x minus 2 and x plus 3? Simply multiply the two together. This is going to be the LCM, least common multiple. It doesn't even have to be a least common multiple, but just a common multiple. Any common multiple is what we need. That's the easiest way to get it, though. So just multiply your left side by x plus 3 over x plus 3, and then multiply your right side by x minus 2 over x minus 2. Whenever you have a fraction times a fraction, you want to assume that there are parentheses around the numerator and denominator. So what are you going to end up with here? X plus 3 times 3 over x plus 3 times x minus 2, and x minus 2 times 3 over that same denominator of x minus 2 times x plus 3. What we can do now is we can actually combine the numerators into one numerator, making it x plus 3 times 3 minus x minus 2 times 3 all over x plus 3 times x minus 2. And as you can see, we've converted it into the type of problem that we had earlier. So let's go ahead and simplify this numerator by distributing. We'll get 3x plus 9 minus 3x minus 6 Okay, some things cancel here. So you get 9 plus 6, which would be 15, over x plus 3, x minus 2. Yeah, now we can try to analyze this and see when it would be the case that we have a fraction greater than or equal to 0. So, one possibility is that our numerator is positive and our denominator is also positive. But the numerator could be also, technically, it could be 0. Okay, so as long as our numerator is positive or 0 and our denominator is positive, then we will have a result that is greater than or equal to 0. I'll call that possibility 1. Possibility 2 could be if we were to have a negative numerator, or 0, and if we were to divide by a negative, that would come out greater than or equal to 0. That would be possibility 2. Those are the only possibilities, I think. So what do we need, though? We need for the 15 to be positive or 0, so that would be him being greater than or equal to 0. And you need your denominator, x plus 3, x minus 2, that thing needs to be positive. Notice that he cannot be 0. If he was 0, that would be undefined. So you just have to be careful about not including that line under the inequality. Okay, this is going to be an or between them. So now we could have it where our numerator is negative or 0, and denominator must be negative. Now keep in mind that in this case, it's clear that like the numerator is not less than 0. But I'm just showing the steps of like how you would do this in case you had a numerator that wasn't just 15. Okay, so I think we get that. That looks good. So now let's see which of these statements is true, which is false. Like, what are the solutions to these statements? So this one is just always true. 15 is a positive number, so it's greater than or equal to 0. So we're all set with that. When it comes to this guy, though, we have to solve him. So he needs to be analyzed in a similar way that we analyzed the fraction above. When do you get a product of two things being positive? Yeah, and let me write this down below because there's a couple possibilities. One possibility is that your left factor is positive and your right factor is positive. If they were multiplied, then you'd make a positive. But it's also possible that your left factor could be negative and your right factor could be negative. That would also lead to a positive result. So there's, within this thing, two possibilities. So let's analyze them both. So it could be x plus 3 is greater than 0 and x minus 2 is greater than 0. Or x plus 3 is less than 0 and x minus 2 is less than 0. So let's solve this down here. So, for our final results, on the left side, we need numbers that are both greater than -3 and greater than 2. The two individual number lines that would create would be this and this. But you only take the intersection of the two. What's the intersection of these two? It's numbers that are greater than 2 only. Because it has to meet both criteria, so our final result is any numbers that are greater than 2. Okay, now let's try the other side. Or one of our solutions is numbers less than -3. The other one is numbers that are less than 2, so it goes this way. And then you gotta find the intersection of those. This is numbers that are less than -3. So what does this create? Put them on top of each other, those results. It's an OR that we're doing here. So with the final results, we actually merge them together into one final number line, where this guy gets brought down. And so we can say that our final result for this is from -infinity to -3, unioned with numbers from 2 to infinity. That was just the result of this. Now we have to analyze the right side as well. So luckily the right side is fairly easy. This first statement right here, right off the bat, is false. 15 is not less than 0. And so even though you could analyze cases where your denominator would be negative, there's no point in doing so, because you're finding an and with something that's false. So whatever the solution set is there, the result is going to be no solution for this entire side. Okay, so final results, we have this, or, because we have to put our left side together with the right side, no solution. But if we put them two together, anybody who's part of the left side or the right side is kept in our final result. Therefore, our final result should be just this left side. Let's check it on Desmos and see if that is correct. I'm going to graph this side right here to see when is it positive. Yeah, so as you can see, there are regions where he's positive and regions where he's negative. At an x of -3, there's an asymptote where it switches from being positive to being negative. Then also at x equals 2, there's another asymptote. So the regions where he's positive are going to be to the left of -3 and to the right of 2. You can't have your x be 2 or -3. They can't be part of the solution set because they're not part of the domain.